Let's practice working with some properties of logarithms. And remember that I'm using natural logs here with the ln notation, but any other logarithm would do. Log base 10, log base 2, log base 6, whatever it is, the properties stay the same. In particular, we are looking at the properties that say that the log of a product is the sum of the logs, the log of a quotient is the difference of the logs, and the log of an item with an exponent allows you to drop that exponent down in front. And so if we have a big clump of expressions inside a single logarithm, we may want to expand that or disassemble it into simpler logarithms, such as just multiples of an individual log of x, log of y, log of w, and that's a log of z right there. So the first thing I'm going to do is disassemble this using the properties that say that the log of a product is the sum of the logs of those items involved in the product. And I could break this apart into 4 pieces right away, but let's do it stepwise. Let's recognize that the log of this bunch of stuff up here is the log of x to the 5th over w times y squared over cube root of z. And so one property of logarithms allows me to recognize that structure and just separate the log of the two products. And then each of these is the log of a quotient. The rules allow me to separate that as the difference of the individual logs, like so. And then here comes the other pair. Like that. And then we have a property of logarithms that says, hey, if you have the log of an item to an exponent, that exponent gets to bop down in front. And so we can write this as 5 times the natural log of x. Natural log of w is just hanging out. This third term becomes 2 times the natural log of y. And this one, well, remember that the cube root of z is the same thing as z raised to the 1/3 power. And so boom, drop down the 1/3, and there we have it. And so we've completely disassembled this original clump into 4 individual logarithms. We could have gone from here to here right away, or we could have written this whole thing as the log of x to the 5th times y cubed minus the log of w times cube root of z. And then those pieces would disassemble. No matter how you do it, you're getting to here. Now, we can do this in reverse and have a look at these particular expressions and say, you know, it's nice to see them as separate logs, but maybe we can combine them into a single logarithm. And so, first thing we do is let's set the 1/2 to the side for a minute. It is a factor on both of these. Like that. And now we can look at these logarithms and say, hey, look, it's a difference of 2 logs. It's the log of this large item minus the log of that large item. So we can work our subtraction versus quotient property in reverse and write that as the log of a quotient instead of the difference of the 2 individual logarithms. And now we're basically done with the logarithm business, but here we can recognize, hey, I bet that numerator factors, and in fact it factors into x minus 4 times what, x plus 3, and there's still an x minus 4 in the denominator, and look at that, cancellation. And so this thing simplifies all the way down to 1/2 times the natural log of x plus 3.